Hi, everybody. My name is Rachel Blinoff-Mudd, and I'm a curriculum and instruction manager here at iCEV. I'm excited to share with you some new STEM content we have on our site. As a former CTE teacher of 10 years, I think we have a lot of cool elements that are going to make your life a little bit easier. So let me go ahead and share my screen here. So these are the courses I'm going to be talking about today. These first three are brand new, 100% adopted with the Texas Proclamation 24. And these last four are just new courses that we've added in our STEM content library. So starting off with engineering design and presentation 1 and 2, these are two courses that are focused on having students actually design products and then present them to their audience members. They build on each other. So one's more of an intro and two is a little bit higher level. So within each course, you're going to have a mix of types of lessons, PowerPoints, videos, demonstrations. What I think is really cool within these engineering courses is they include these design challenges. Design challenges are these student projects where they're designing specific things. So in this one, they're designing a cargo transporter to move boxes efficiently in a certain amount of time. What's really wonderful about the design challenges is they're all video lessons where we have our expert, who's a former engineer, walking students through everything they need to know to design it without designing it for them. So he walks them through, here's the materials you should be able to use, which is what you're watching now. But then he also walks you through, here's some considerations you need to be thinking about. Like in this one, when he's talking about wire strippers and cutters, he's probably talking about safety here, things you need to be considering when using them. And again, he walks them through everything you need to actually build this cargo transporter. The other great thing about design challenges, whether it's this one or another one, is there's these teacher videos. These are teacher instructional videos where he walks you through, here's what you need to do set up. Maybe you need to prep this. Maybe you need to make sure this is ready to go. He also walks you through some troubleshooting tips and tricks. So he's anticipated what the students are going to run into as they're building their products and gives you some tips and tricks on how to navigate through that. The other really wonderful thing about these design challenges is that we have been very intentional that they could be used by a variety of different teachers, whether you have a tiny budget or a big budget. David does a great job at saying, hey, if you need a cheaper option, you can use this. Or if you have room in your budget, this is the cool thing that you could be using. So he does an excellent job at really making sure teachers with all different types of budget can be doing these builds. Each design challenge comes with an engineering notebook. Well, that was the downloaded version. Let me show you what that looks like. It walks students through the whole design process from prototyping to testing to building out different iterations. Let's see, here it is. So this is the one specific to cargo transport. Again, it will break down based on the engineering design process. So the planning part, the sketching, again, we just give them steps that they need to follow. So this combined with the videos, the students have a lot of information they're going to need to work through this build. So those are our design challenges. The other cool thing in design challenges is that a lot of them come with some pre-design challenge type of assessment or something they might need to be able to successfully do the design challenge. The other thing in these engineering design and presentation courses 1 and 2 is they both have these capstone lessons. So a capstone lesson is designed to be a long project-based learning experience for students where we give them a prompt and they get to navigate through their solution to the prompt. So in engineering design and presentation 1, we've outlined exactly what teachers need to do. Here's the different sections they're going to do. Here's how much time it should take. Well, we recommend 15 days, so that's 3 weeks. There is the flexibility. So if you want to make it shorter, you can cut out some of these portions. If you want to make it longer, you could definitely add on what's needed. The really cool thing about these capstone projects is there's no instructor-led content delivery. Instead, we're relying on this thing we call the capstone library. So if we navigate through this resource library, this is a series of videos that students might need to watch if they're not familiar. So maybe they're building something that needs a sensor. Instead of you having to teach the whole class or maybe just one student about a sensor, David's here to kind of walk them through the basics of how to use a sensor and install it into your design. What are some considerations you need to be thinking about when you're using a sensor? So he's gone through and identified all these different common materials, tools, things that student might use in their build. And then they can quickly reference, maybe they want to use a 3D printer and maybe you're not familiar with the 3D printer. Well, David went in and gave 2 quick videos to update, get students on pace so they could use a 3D printer for their design. So that's the really cool part about the capstone. The other thing that comes with the capstone is the engineering notebook. So this is the main thing students will use as they navigate through the capstone library and as through the capstone project. They'll go through it, it'll give them prompts, things they have to answer, and then they'll come across these stop signs with these activities they have to complete. So what these activities are these are intentional points where they stop in the project, kind of gather their thoughts and summarize them, and then meet with their teacher to discuss. And this is a really good way for the teachers to ensure students are progressing appropriately, they're on the right track, that they're doing things that they should be doing. So those are the capstone projects. Again, the other engineering design and presentation course has the same setup. It's really focused on designing products, presenting them to the audience, just at a little bit of a higher level, also has a capstone lesson. Principles of Applied Engineering is a little bit more focused on the concepts needed for engineering rather than the design process. So it touches a lot on all the different things, robotics, electronic theory, just basic computer aided drawing, just a little bit of everything so students get a good feel for what concepts need to be mastered to be a full engineer. We also have those design challenges and capstones within this course. The non-Proc24 courses that we have added to the site are all brand new. They're just not aligned and approved with the state of Texas. We have scientific research and design. In this one, it really focuses on the scientific method and its applications. It walks students through what each step of the scientific method looks like. It has a lab challenge, which is similar to a design challenge, but rather than designing a product and building something out, they're testing a scientific theory or idea. And in this one, they're practicing experimental design using Mentos and Coke bottles to get that fun explosion and seeing, does Diet Coke, does it happen to do the same thing? Do Fruity Mentos do the same thing? So it really walks them through that experimental design process. Also has a capstone in here for students to put together their own scientific research project. We also have engineering design and problem solving. This is a course focused on the engineering, again, design process and how do you find solutions for problems. Very similar to engineering design and presentation courses, but it goes more in depth on the technical pieces that are needed to be a successful engineer. Also has design challenges and capstones. Finally, we have engineering science, and principles of technology. Engineering science is really focused on the concepts of engineering. So a lot about thermodynamics, manufacturing, energy, motion, a lot more physics tied into engineering, but we still have our design challenges and there is a capstone project. The last course, principles of technology, I would call this physics. It's essentially main physics concepts as they relate to engineering. So it's a really higher level focused content, not so much focused on designing products, but more on the physics content as it applies to engineering. Again, you'll see a lot of lab challenges in here for students to practice applying scientific theories, and then they'll understand how it can relate to engineering. So while we're here, I just wanted to jump in one lesson plan so I could show you the fun features we have added to our lesson plans. So this is what a lesson plan looks like. We really go through and walk through step by step. What does a teacher need to do to be successful in class that day? As a former teacher, I would rely heavily on this. So I knew what I was doing each day, and then I could give myself some capacity to focus on classroom management. So they all have bell ringers, so things that students can do while you're taking attendance or getting absent students caught up. They all have exit tickets to give you that quick little summary of where students are at when they leave for the day. And then again, it just shows you the progression of how you should use all the materials provided to you in a lesson. A really great thing we've added to our lesson plans is this accommodations, modifications, and extensions section. We give an overview of each activity or project, and then we've described how you can change it up for a student with a 504 plan or an IEP, or maybe a student who's advancing quickly and needs something to do, then you could use that extension opportunity for them. We've also updated our resources to be HTML based. So whether you open a lesson plan or maybe you open an activity, what this means is you're able to use a Google Translate feature built in, and you can select a language maybe your student is more comfortable in, and then it will automatically apply it. You can print this out and provide it to that student. So some really cool features that we've added to our iCEV STEM site, and I'm looking forward to hearing your feedback. Enjoy.